Hello dear students, I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. Today I will discuss you about the different type of pretreatment. So in this lecture series of this solid waste management, we are at this point where we are discussing about the transformation of waste. Before I have discussed you about the collection of waste, primary collection, secondary collection, and then from secondary collection to its transformation of waste. So now we are at this point where I have already discussed you about the anaerobic digestion process. So anaerobic digestion process will involves in this what happens, a microbial activity will be carried out for this organic treatment of the solid waste in the absence of oxygen. It is called as anaerobic digestion. So anaerobic digestion will be very much useful because from anaerobic digestion we will get biogas, and biogas is mainly composed of methane. So this methane will helps in the production of biogas and for the electricity generation. So this biogas is very much useful. So in here we are discussing about the pre-treatment. Pre-treatment means the treatment of the substrate that we are going to add into the digestion chamber for anaerobic digestion. So the treatment of substrate, how it will be treated. So the substrate is like, sometimes we'll add sludge, biomass sludge, or some energy crops like sunflower waste, or crop waste will be there. So all these are added into the anaerobic digestion process so that it should be pre-treated before adding it into the digestion chamber. Because if we'll pre-treat it with their some methods, then it will work better and we will get better biogas. So first point is about this pre-treatment. Pre-treatment means like process of initiating or improving the efficiency of microbial attack on a substrate or biomass. So pre-treatment we will do for the process. Pre-treatment is mainly a process where the initiation or improvement has been done to increase the efficiency of microbial attack on a substrate. So to increase the efficiency of microbial attack will be there inside the chamber. So to increase its attack of these microbes on this residue. So what happened? Pre-treatment is basically, it is a process that will involves initiating the process to improve the efficiency of microbial attack on the substrate. So it involves like the process will start with some treatment so that the microbial activity or microbial attack will be more on the substrate or the biomass. So during this pre-treatment process, what happens? The compact structure of the biomass is disrupted and exposed to the microbial attack. So the compact structure of the biomass will be disrupted. So in this way, what happens? When it will comes in contact with some microbial activity, the structure will be disrupted, and the disruption will cause in this way the substrate can be work better during the microbial attack process. So this pre-treatment is very much important before we are adding the residue, before we are adding the things into the anaerobic digestion chamber. So for this pre-treatment process, basically three processes will be involved. First is the physical process, then chemical process, and biological process. So physical process will involve the reaction of the combination and irradiation of the residues substrate. So physical reaction will basically involve some radiation will become. So that radiation will break down the cellulose of the cell wall. Like what happened? Lignocellulose will be there. So this lignocellulose will be compacted, or it will be formed inside a layer. So that layer may be break down with the irradiation process, or sometimes it will be going throughout a chemical reaction process. So this chemical reaction will mainly causes the alkali, acid and wet oxidation process will be involved. Sometimes for chemicals, what we are using some alkali treatment, some acid treatment, or some wet oxidation treatment. And next is the biological treatment. So in biological treatment, some fungi and some enzymes is involved for this pre-treatment process. This pre-treatment process is very much required for reducing the HRT time, or sometimes like what happened, hydraulic retention time of the whole reactor process will be reduced when this type of process will be done. Then when the pre-treatment has been completed, for all the substrate that we are adding inside the chamber. So this pre-treatment is basically a process of initiating the anaerobic digestion process that will going to improve the efficiency of the microbial attacks either on a substrate or on a biomass. So for this pre-treatment process, three methods has been used. First is a physical method, chemical method, and then biological method. So physical will involve some radiation, some effects of some radiation on the substrate, or chemical in the form of like alkali, sometimes acid treatment, wet oxidation treatment, and sometimes biological fungi or enzyme treatment will be there. Next is that this treatment technology will ensure the biomass degradation. Like this treatment technology will be helpful for the degradation of the biomass, for the disintegration of biomass, like then only that it can be go further for its better attack by the microorganisms. When the microorganisms will be attacked, if this pre-treatment process has been still completed, then the reactor speed and the reactor work will be fast, and this integration and it will be going to improve the solubilization of this material in order to overcome the biological limitation of anaerobic digestion. So in order to reduce the biological limitation of anaerobic digestion. So in anaerobic digestion, what happened? Some biological limitation is there. So what type of limitation? Like the microbes, sometimes microbes will be not be able to degrade or not be able to decompose the organic materials that is present in the chamber. So to overcome, to sort out this problem, because some biological limitation is there, so these microbes will not be able to act properly for the substrate. So if we will not do the pre-treatment before adding it into the chamber, then what happen? Then this process will not take place completely, and the hydraulic retention time will also increases. So to avoid all these kind of conditions and to avoid this limitation, the biological limitation, like the activity of these microbes, for these things only this pre-treatment technology will be there. Pre-treatment technology has been introduced, and by this pre-treatment process, any substance that is not only biogas yield can be increased, but also the high calorific value. Not only the biogas yield, but the high calorific value of the gas can be obtained, leading to less effort in purification for the biomethanation process. So this this pre-treatment will be helpful for the biogas yield, will be helpful for the biogas. Basically, we are doing this anaerobic digestion process to obtain the biogas. Okay, so to obtain the biogas, this anaerobic digestion process has been done, and this biogas process can be increased, but also a high calorific value of the gas. It will be increases the high calorific value of the gases, and that will be obtained, leading to less efforts in purification for the biomethane production. So that can basically obtain, and it will be leads toward the less effort will be there for the purification for the biomethane production. So for the production of biomethane, this pre-treatment will be helpful for the less effort will be there in the purification of biomethane production. So this pre-treatment of any substrate will be very much useful, because obviously we'll get a good condition, good biomethane productions also, but it will be increased with the high calorific value of gases. So the if the calorific value of the gas will be high, then the gas features is also good. So it will be able to produce more heating capacity. And second point is that the methane production is also increased because of this type of treatment. Now, first is the mechanical pre-treatment. So mechanical methods will be involved for this pre-treatment. So mechanical pre-treatment is like it will reduce as the particle size and break down the crystalline structure. Like crystalline structure will be there, like particle of size -1 to 2 mm for effective hydrolysis of lignocellulose. So particle size is like 1 to 2 mm, and this 1 to 2 mm will be going for the hydrolysis process. Hydrolysis of lignocellulose. And basically this mechanical pretreatment, what it will it will increases the specific surface area, and enhancement of it will helpful in the enzyme degradation also. So it increases the specific surface area and enhance the enzyme degradation rate. So what are the different pretreatment techniques? So the pretreatment techniques are, first is the knife mills and shredders, hammer mills, and ultrasonic treatment. So knife mills and shredders are there, hammer mill is also there, ultrasonic treatment. So these are the some techniques that involve for the pre-treatment of this substrate, so that before entering it into the before making it into the anaerobic digestion chamber, this will be pre-treatment will be done for the substrate, so that we'll achieve a very good result. So next is the ultrasonic treatment. In ultrasonic treatment, what happen? Ultrasound treatment can be used as a pre-treatment for sludge or to treat the liquid effluent for anaerobic digestion. Like this, ultrasonic treatment will be involved. It will be used for the pre-treatment for sludge. Pre-treatment for sludge or to treat the liquid effluent from anaerobic digestion. Anaerobic digestion will be there, and that anaerobic digestion, in that process, this ultrasound treatment involves the use of some ultrasound light. So this ultrasound treatment will be like pre-treatment of sludge and treat the liquid effluent from anaerobic digestion process. Next is the ultrasound frequency will be there. So that frequency is like 20 kilohertz, 20 kHz. So this ultrasound frequency causes cavities to form and implode, and producing shock waves. The process is called cavitation. So this ultrasound frequency will be going to form and implode and producing some shock waves in a process called as cavitation. These forces causes the microbial cell wall in the liquid settling hydrolytic enzyme free, increasing the hydrolysis rate of the biomass. So what it will do, it will causes the disruption of microbial cell wall, means the cell wall will be disrupted, and then liquid settling of hydrolytic enzymes and increasing the hydrolysis rate of biomass. So first is the disruption of cell wall and liquid setting hydrolytic enzyme free, liquid setting hydrolytic enzymes free. So and all contributed toward the hydrolysis rate of biomass. So ultrasonic treatment is a treatment that involves the use of ultrasounds, and that will be that frequency is also like 20 kilohertz, and that is causing cavities to form and implode. Producing shock wave in a process called as cavitation, and it will produce some shock waves in that process, which is called as cavitation. So these forces cause the disruption of microbial cell wall in the liquid settling hydrolytic enzyme free and increasing the hydrolysis rate of the biomass. Next is the here you can see the pictures of this. Is a picture of an industrial shredder in Austria. So Australia, because in foreign they are using more instruments, so this is an industrial shredder will be there. So pre-treatment of feedstock for enhancing biogas production. So when we are talking about a production of biogas on a very larger level, so this pre-treatment is very much required, because when we already we have explained why this pre-treatment has required. Pre-treatment will enhance the microbial attack activity. Third thing is that pre-treatment will helpful for the production of methane also, and the methane which will be produced will be having more very good composition of this calorific value. So the gas we are getting will be having very good calorific value. And the methanation and methane is also one criteria. And see, this is a picture of a cross flow shredder, like a mechanical pre-treatment unit. These are the mechanical pre-treatment units. Pre-treatment of food stock for enhanced biogas production. So these are the mechanical pre-treatment where all the substrate will be added for the pre-treatment unit. Next type is the thermal pre-treatment. So thermal pre-treatment, what happens? Substrate is heated, like typically 125 to 190 degrees Celsius, 125 to 190 degrees Celsius. And this substrate is heated at a very high temperature and held at that temperature for a particular duration, and it will be stopped at that temperature for a particular duration. So in the laboratories, this can be carried out with autoclave. Obviously, some autoclave will be there, hot air ovens, and water bath and microwave heater. So these four instruments are there for this thermal pretreatment of solid waste in the labs, and that four instrument is like autoclave will be there, some hot air oven will be there, water bath, and microwave heater. So in autoclave, it will be also again the making it like on a very high temperature, boiling it in a water on a very high temperature. Same thing is there for hot air oven will be there, water baths, and microwave heater. So and next point is about the lignocellulose substrate. The presence of heat and water disturbs the hydrogen bond that holds together crystalline cellulose and lignocellulosic complex. This is causing the biomass to swell. So the lignocellulosic substrate, the presence of heat and water disturbs the hydrogen bond that holds together crystalline cellulose and the lignocellulosic cellulose complex. This is causing the biomass to swell. So this will be given by this Garrett et al. In 1999. So the lignocellulose substrate is there, and the presence of heat and water disturbs the hydrogen. So the presence of heat is there, some water is there. So they are going to disturb the hydrogen bonds that hold together crystalline cellulose. So they both the water and hydrogen will hold together the crystalline cellulose and the lignocellulose complexes, which is causing the biomass to swell. So these are the process where we have talked about the which type of instrument is used for the thermal pretreatment. So it is like autoclave will be there, hot air oven, water bath, and microwave heater. And dry substrates are the substrate that will be additional water before the thermal pretreatment. So here you can see the pictures of this autoclave. This is the autoclave machine where we will put the substrate into inside this chamber, and it will be works on the very high temperature, and it will be boil the substrate to make it free from pathogens. Next is hot air oven. Hot air oven is a picture. See, this is a picture of hot air oven where you can put inside these things inside the chamber. Next is the microwave oven. It will works on the principle of microwave. Next is the hot water bath. Here some hot water bath will be given to the substrate for the pre-treatment process. So thermal pretreatment is only effective up to a certain temperature due to formation of inhibitory compounds at temperature beyond decreasing the biogas yield. This thermal pretreatment is only effective up to a certain temperature because of the formation of inhibitory compounds at a temperature which is beyond decreasing the biomass yield. So during pre-treatment of lignocellulose compounds, during the pre-treatment of lignocellulosic compound with a very high temperature, and certain dark colored xylose and lignins breakdown product are there which is formed. Some xylose and lignin breakdown products are there which is formed, and that includes heterocyclic and phenolic compounds such as furfural, which is toxic in nature. So during pretreatment, what happens, this lignocellulosic compound is there. That compound can work at a very high temperature. So something during this dark colored xylose will come and lignin break down the products, and which is formed, that includes heterocyclic and phenolic compounds like furfural, which is toxic in nature. Next is if the temperature is above 200 degrees Celsius, this has been found responsible for the production of recalcitrant substance. Recalcitrants means leads to the biodegradable soluble organics. Recalcitrants means biodegradable substance. Biodegradable substance. So temperature above 200 degrees Celsius has been found responsible for the production of some biodegradable soluble organics or toxic or inhibitory intermediates during the pretreatment process. So the pretreatment of lignocellulose compound at a very high temperature, and certain dark colored xylose and lignin breakdown will be there. So that products are formed, and which includes basically some heterocyclic and phenolic compounds such as furfural, which will be very toxic in nature. So this will be like, here we have discussed about the thermal pretreatment, and it is only effective up to a certain temperature due to the formation of inhibitory compound at temperature beyond decreasing the biogas yield, and the temperature if the temperature is above 200 degrees Celsius, these have been found responsible for the production of some biodegradable soluble organics or toxic or inhibitory intermediates during the pretreatment process. This is the picture. That picture will represent the industrial scale thermal pretreatment in the Germany. So the optimum temperature condition that break down the substrate should be evaluated, which varies from substrate to substrate. Optimum temperature condition that break down the substrate, it will be evaluated, and which it will be varies from one substance to other substance. Obviously, optimum temperature condition will be vary for some fatty substance, for some organic like some protein will be there, for some carbohydrate will be there. So the temperature condition will be vary and break down the substrate, and it should be evaluated, and it is going to be evaluated which varies from the substrate to substrate. Next disadvantage about this thermal treatment is that the energy requirement is huge, so potential benefit energy requirement is huge, so the potential benefit should surpass the energy investment. Energy requirement is huge, so the potential benefit should surpass the energy investment. See, this is the picture of industrial scale thermal pretreatment in the Germany. And in this, what happened? The optimum temperature condition will be there that break down the substrate, and it should be evaluated, and that varies from substrate to substrate. Next type of pretreatment is the chemical pretreatment. So chemical pretreatment uses a range of different chemicals, mainly acids and bases of different strength, so under different condition. So this chemical pretreatment is going to use a range of different chemicals, mainly which is acids and bases will be there. So this two type of chemical treatment will be there, that is acids and bases. So these two, what it will do, some type of chemical pretreatment are like alkali. Alkali pretreatment will be carried out with some different alkali. So alkali will make the acidic condition into basic with different strength under different condition. So the lime will be there, sodium hydroxide, calcium hydroxide, CaOH twice, lime, sodium hydroxide and calcium hydroxide. Alkali addition causes swelling of lignocellulose and disruption of lignin with partial solubilization. So this alkali pretreatment will work on the alkali addition causes swelling of lignocellulose and disruption of lignin under lignin with partial solubilization. So the chemical pretreatment uses a range of different chemicals like acids and bases and different strength under different condition. And for alkali, some lime, sodium hydroxide, calcium hydroxide is used, and alkali addition causes swelling of lignocellulose and disruption of lignins with partial solubilization. Next, we'll discuss about the acid pretreatment. So acid pretreatment is like some lignocellulosic substance are there. Acid pretreatment does not disrupt lignin as in the case of alkali pretreatment, but breaks hemicellulose and disrupts ether bonds between lignin and hemicellulose. So acid pretreatment is that type of treatment in which what happened, the lignocellulosic substrate will be there. So acid pretreatment does not disturb the lignin, but in the case of alkali pretreatment and breakdowns the hemicellulose and disturbs ether bond between lignins and hemicellulose. So this lignocellulose substrate will work like that. The acid pretreatment does not disturb the lignin and alkali pretreatment, but breaks down the hemicellulose and disturbs both bond between the lignin and hemicellulose. Oxidative pretreatment will be like, it uses hydrogen peroxide and ozone. And disadvantage of this oxidative pretreatment is that too much oxygen into the system increases the proportion of CO2 in the biogas. So doses has to be optimized for each substrate. So optimization is very much important for this oxidative process, because what happened, optimization is important, very much important for this oxidative pretreatment process, because too much oxygen will be there, and that oxygen into the system, it is increases the proportion of CO2. The proportion of CO2 is going to be increases in the biogas, and the doses has to be optimized for each substrate. So in the biogas, what happened, the doses has to be optimized. Optimization will be there for these doses, and much oxygen into the system increases the proportion of CO2 in the biogas, and doses has to be optimized for the each substrate. That's why we have to take care of the doses of the substrate. Next type of treatment is the biological treatment, pre-treatment. Biological pre-treatment involves using microbial agents like bacteria, fungi and enzymes. So these three are there, that is bacteria, fungi and enzymes. So these three will involved in the microbial pre-treatment process using microbial agents for biogas enhancement from the substrate. And the complex biopolymers are there, that is protein and carbohydrate, can be transformed into the simpler end products due to the action of various enzymes produced by the bacteria, and then which in turn solubilize the organic compounds present in the biomass with minimum energy, with no major change in the substrate environment. So the complex biopolymer process like protein and carbohydrate can be transformed into the simpler end product due to the action of various enzymes produced by the bacteria, and this will be like in turns solubilizes the organic compounds present in the biomass. This will be like solubilize the organic compounds present in the biomass with minimum energy, with very nominal or very less energy, and this will be no major change in the substrate environment. And biological pretreatment with microbial agents leads to an increase of 29.54% in the biogas yield as compared to the non-biological process. But these processes are much slower than non-biological process. So this biological pretreatment is very much useful when we compare it with some physical or chemical treatment, because the biological treatment will involve by using some microbial agents like bacteria, fungi and enzyme for the enhancement of biogas, and some complex biopolymer will be there like protein and carbohydrate that can be transformed into the simpler end product due to the action of various enzymes. So the biopolymer can be transformed into the simpler end product due to the action of various enzymes produced by the bacteria. Then what it will do, which then in turn it will going to solubilizes the organic compounds present in the biomass with like a minimum energy, with some very less energy, and no major change is there in the substrate environment. So the substrate quality or substrate environment is not changed, because what happened, the complex biopolymer like some protein and carbohydrate can be transformed into a simpler end product because of the action of these enzymes, and this will be going to produce by the bacteria. Then it will be turned and solubilizes the organic compounds. Then it turns and solubilize the organic compounds present in the biomass, and it will be like very minimum energy will be there, no major change in the substrate environment. And the biological pretreatment with some microbial agents lead to an increase of 29.54% in biological pretreatment with microbial agents leads to an increase of 29.54% of biogas yield as compared to non-biological process. But these processes are much slower than the non-biological process. And biological pretreatment is applied by using direct microorganisms as well as some enzymes extracted from the microbes as catalyst to modify and to degrade the complex biomass polymer. So biological pretreatment is applied by using some direct microorganisms like enzyme extracted from microbes or catalyst to modify and to degrade the complex biomass polymer. These are less energy intensive pretreatment with high selectivity. This is like a very less energy intensive pretreatment with very high selectivity and no inhibitory byproducts, and mild operational condition will be there. And the disadvantage of this biological pretreatment is like that the cost and the complexity of formulating the optimum biological agent mixture. There is a very less energy intensive pretreatment with high selectivity, no inhibitory byproducts, and mild operation condition will be there. And the disadvantage is like the cost and the complexity of formulating the optimum biological agent mixture. Now, the what are the different biological pretreatment methods? First is the anaerobic microbial treatment. So, anaerobic microbial treatment is going to utilize microbial fermentation under anaerobic condition. So, pH and temperature is the pretreatment reactor, and it is well suited to hydrolysis enzymes. pH and temperature is in the pretreatment reactor is very much suited to the hydrolysis enzymes, and the microorganisms present in this activity can break down chemicals. It can break down the chemicals that might be otherwise inhibit methanogenesis in the anaerobic digester. So the temperature, pH and temperature in the pretreatment reactor is well suited to hydrolysis enzyme, and the microorganism presence can break down chemicals that might otherwise inhibit the methanogenesis in the anaerobic digester. Aerobic microbial treatment is that treatment which will be carried out with some naturally occurring mixed microbial culture, like we can say. Its example is like in lignocellulosic substance, some aerobic organisms like some bacteria, it will be produces cellulose and hemicellulose or lignins that is degrading the enzyme rapidly and is a large amount which solubilizes the substrate. So the lignocellulose substrate is that where aerobic bacteria are there that are producing cellulose, hemicellulose or lignins are there. They are degrading the enzymes rapidly and in large amount they solubilize the substrate. So considerably what happened, faster process, but if the pre-treatment phase is too long, a lot of organic matter could be degraded to carbon dioxide instead to methane. So this process is basically a very faster process. But if the pre-treatment phases is too long, the phase is going to be very long, a lot of organic matter could be degraded and the carbon dioxide will be released instead of the methane. So this microbial treatment is sometimes not work properly, because whenever it will be going to be too long, then the degraded carbon dioxide is going to produce. And the lignocellulosic substance is that substance, some aerobic organisms are there, they are going to produce cellulose or hemicellulose or sometimes lignins also, and degrading the enzymes rapidly and in large amount, they solubilize the substrates also. And a fungal treatment will be there. Next is the fungal treatment. For fungal treatment, fungi will be there such as white rot fungi, and they are known for their ability to remove environmental pollutants from solid and liquid base by delignifying the substrate. So these fungi are the mostly white rot fungi is there. They have the ability to remove the environmental pollutants from the solid and liquid waste by delignifying the substrate. And in this process, they increases the solubilization and biogas. In this process, they are like increasing the solubilization in the biogas yield, and the pre-treatment of lignocellulosic substrate like some wheat straw will be there with white rot fungi that degrades lignin that have been investigated for the various researcher. So fungal treatment is like white rot fungi will be used, and they are known for their ability to remove the environmental pollutants from solid and liquid waste by delignifying the substrates. So in this process, they increases the solubilization and biogas yield, and pre-treatment of lignocellulosic substrate with white rot fungi that degrades lignin have been investigated by various researchers. And the next is the enzyme addition. Enzyme Next, we'll discuss about the enzyme addition. Enzyme addition is like it will be added to enhance the biomass breakdown. A mixture of enzymes can be added which may include cellulose, hemicellulose, pectins, starch degrading enzymes. So enzyme additives can be applied in three different ways. First is the by direct addition to the single stage anaerobic digester. Next is the by addition to the hydrolysis and acidification vessels, like first stage of a two-stage system. By addition to a dedicated enzymatic pretreatment vessel. So enzyme addition will be done for the pretreatment process. So what it will do, it enhances the biomass breakdown, and a mixture of enzymes can be added that may include cellulose, hemicellulose, pectins, and starch degrading enzymes. And these additives can be applied in some three ways. First is like either by direct digestion or single stage anaerobic digester, by addition to the hydrolysis and acidification vessel. So, and next is the by addition to the dedicated enzymatic pretreatment vessel. And this is about the enzyme addition to the pretreatment process. This is the some of the references or some of the textbook that has been followed for studying this lecture. So if you want to do some depth analysis, if you want to study in depth, you can follow this textbook. And now I'm going to conclude my lecture. So this pretreatment process part has been done. By which methods the pretreatment should be done. So we have a study about the physical, chemical and biological methods. Which method is suitable and which method will having what disadvantage. Okay. So if you have any query, if you have any question regarding that lecture, you can write in the comment box, or you can mail me on my given mail ID, that is shikha.pandey@gmail.com. And thank you for today's lecture.
Like, share and subscribe. Hit the bell icon for more updates.